Next, we discuss defines Poisson's trial. How to differ from Bernoulli trials. So, what is the difference between Bernoulli trials and Poisson's trials? Solutions. Solutions. A sequence of independent trials of a random experiment, the sample space or event space of which contains 2 points, success and failure, each called Poisson sequence of trial if the probability of success is not constant. If the probability of success is not constant, but it varies from one trial to another. The probability of success is not constant from varies from one trial to another trial. This is called Poisson sequence of trial. But Bernoulli sequence of trials, the probability of success or the probability of failure of probability of failure remains constant for all the trials. The probability of success or probability of failures constants for all trials. Okay, this is the common difference. Next, we discuss another important topic. Obtain Poisson approximation to the binomial law of probability, or if the constant p be the constant probability of success in a sequence of n Bernoulli trials, then show that limit n tends to infinity nci p to the power I 1 minus p n to the n minus to the power n minus I equal to e to the power minus mu to the power I by I factorial I running from 0 1 2 dot where n is the large number and p be the small, such that np equal to mu, where mu equal to np, a positive constant. We prove it, given that np equal to mu. Proof. We know that the probability of I success in a sequence of Bernoulli trials with constant probability of p success is pai equal to nci p to the power I 1 minus p n minus I running from 0 1 2 n. We break it n factorial by I factorial n minus I factorial p to the power I 1 minus p to the power n minus I. Given that n is large number and p be the small, such that np equal to mu implies p equal to mu by n. Putting this value p equal to mu by n, we get p to the power ai n factorial means n into n minus 1 n minus I minus 1 into n minus I factorial by I factorial n minus I factorial. P means mu by n to the power I and 1 minus mu by n to the power n minus I running from 0 to 1 n. Mu to the power I factorial mu to the power I by I factorial. In I factorial cancel into the power I. This is total ith elements, and into the power I we divide it 1 n minus 1 by n minus 2 by n dot dot n minus I minus 1 by n. This is means this term 1 minus mu to the power n by n, 1 minus mu to the mu by n by I, mu to the power I by I factorial 1 into 1 by n, 1 by 2 by n dot dot 1 by I minus 1 by n. This means 1 plus 1 by n by minus 1 by n by mu minus n by mu whole to the power minus mu whole to the power minus mu by this is same 1 minus mu by n whole to the power I. We taking limit both side at n tends to infinity, we get limit n tends to infinity p of ai equal to mu to the power I by I factorial. This means e to the power minus mu by 1. Since limit n tends to infinity 1 plus 1 by x by a x by a x tends to infinity, you know that limit x tends to infinity 1 plus 1 plus 1 plus 1 by x by a by x by to the power x by a equal to e if a not equal to 0. So this is mu, this is e, total e, total this is e to the power minus mu from this formula. So e to the power minus mu, hence limit n tends to infinity e to the power ai equal to e to the power minus mu to the power I by I factorial. This is the Poisson approximation of approximation to the binomial tire where I running from 0 1 to dot dot dot. Okay, hence if the probability of success p is small and the number of trials n is large such that mu equal to np, then we have the approximation formula p probability of ai approximate to e to the power minus mu to the power I by I factorial where I running from 0 1 to dot dot dot, where n is big number as p is very small and the product of the obtuse number is a positive constant. Okay, this is the Poisson approximation formula e to the power minus mu to the power I by I factorial. Okay.